Hello friends, myself Surinder Mohandeep, Associate Professor in Mathematics. In this video, I shall explain the concept of regression analysis, how to find the line of regression of dependent variable with respect to the independent variable, and in the last, I shall use Geogebra for the better understanding of the topic. So let us start regression analysis. Definition: regression analysis expresses the average relationship between two or more variables. Linear regression: when the functional relationship between the variables, suppose x and y, when the functional relationship between the variables x and y is expressed as first degree, then it is called a linear regression between the variables x and y. Regression lines: the regression line of y on x is that line from which we get estimated value of y for a given value of x, and vice versa. That is, the regression line of x on y is that line from which we get estimated value of the variable x from the given value of the variable y. Now regression line of y on x, that is, x is the independent variable, y is the dependent variable. So we shall use the method of least squares for finding the regression line of the variable y on x. Suppose we have the n pairs of values x1, y1, x2, y2, and so on xn, yn, where xi's are the values of the variable capital X and yi are the values of the variable capital Y under consideration. Let the line of best fit is y equal to a plus bx. That is, we will predict the value of y for a given value of x, and we will find a and b by method of least squares in such a way that the error, that is the predicted value of y from this equation, and the value of y, suppose y1, y2, yn, the difference between this observed and the predicted value should be as least as possible. So let ei is the error in the observed value and the predicted value of the variable capital Y. That is, ei equals to yi, this is the observed value, minus a minus bxi. This is the predicted value from this relation. So ei is called residual error. So by method of least squares, we will have to minimize this s, this is summation ei square, that is yi minus a minus bxi square. So clearly s will be minimum if, so s will be minimum if curly s upon curly a equal to 0 and curly s upon curly b equal to 0. Curly s upon curly a equal to 0, so we differentiate partially this expression with respect to a, we get minus summation minus 2 times yi minus a minus bxi equal to 0, or summation yi equals to n times a plus b times summation xi, means 1 over n summation yi equals to a plus b times 1 over n summation xi. So call this expression as y naught. So y naught equals to a plus b, and call this expression as x naught, where y naught is the mean of y. Similarly, x naught is the mean of x. So means both the lines of regression passes through the mean y naught as well as x naught. Now we put curly s upon curly b equal to 0. So by differentiating the equation s equal to this with respect to the variable b, we have summation minus 2xi into yi minus a minus bxi equal to 0, or summation xi yi is equals to a times summation xi plus b times summation xi square. So a equals to 1 over n summation y minus b over n summation x, where y is understood yi. Similarly, summation x is summation xi, I varying from 1 to n. And b equals to n times summation xy minus summation x summation y divided by n times summation x square minus summation x the whole square. Now this numerator is nothing but the covariance between the variables capital X and Y, and the denominator is the variance of the variable X. So this is covariance between X and Y upon Sx whole square. So B equals to R times Sx divided by Sy, where R is the coefficient of correlation between X and Y, because we know that covariance is R times Sx, where Sx is the standard deviation of capital X. Similarly, Sy is the standard deviation of the variable capital Y. This B is also denoted by Byx, called regression coefficient of Y on X. So by putting the values of A and B as obtained in the previous slide, we get the regression line of the variable Y on the X. Example, find the regression equation of Y on X of the following data, where X has values 1, 2, 3, 4, 5. When x equals to 1, y is 14. When x equals to 2, y is 27. When x equal to 3, y is 40. When x equals to 4, y is 55. When x equal to 5, y equals to 68. Let the line of the best fit of y on x is y equals to a plus bx. We are given x is 1, 2, 3, 4, 5, y is 14, 27, 40, 55, 68. Now we do x square. So 1, 2 square, 4, 3 square, 9, 4 square, 16, 5 square, 25. X into y is 14, 54, then 120, 220, 340. So summation x is 15, summation y is 204, summation x square is 55, and summation xy is 748. Putting in the equation summation y equals to na plus b times summation x as solved previous article, and summation xy equals to a summation x plus b summation x whole square. We get 5a plus 15b equal to 204 and 15a plus 55b equals to 748. After solving, we get a equals to 0 and b equal to 13.6. So the line of regression of y on x is y equals to a plus bx, but a is 0, so y equals to 13.6 into x. This is the line of regression of y on x. Now we shall make the use of GeoGebra for drawing line of regression of y on x. So what we do, we first of all go to Google, find GeoGebra Classic. Now click on spreadsheet. So here the value of a variable x is 1, then 2, then 3, then 4, then 5, and corresponding values of y variable are 14, 27, 40, 55, and 68. So this was the data given in the example. Now we select this data and we click on this histogram symbol and we click on two variable regression analysis. So we get 114, 227, 340, 455, 568. These are the 5 points. Now we go to this regression model, click on this arrow. Since we are dealing with linear regression, click on this linear. So this is the line of regression of y on x, and this line is y equal to 13.6x as discussed in previous slide. So this is the line of regression of y on x, y equal to 13.6 times x. So if we take x equal to 1, what is the value of y? This is 13.6. Our predicted value is 13.6, but the given value is 14. Y is 14 when x was 1. So this is very near to the observed value. So the error, that is the E1, small e1, is zero point 0.4. Similarly, if we change x equal to 2, so y equal to 27.2, this is a very minimum error. So in this way, this is the line of regression of y on x, that is y equal to 13.6 into x. Thank you.